Now, we're going to try and smash this because this should be stuff that you guys should have been doing for years now. So first thing we're looking at composite functions, which is when we're putting a function into another function to find a new function. So the first example, we've got f of x equals x minus 3 all squared, g of x equals 3x plus 5. So the first one we're going to find is g of f of x. Okay, and that's telling me that I'm putting f of x into g of x where the variable is, because I'm in my notation here I've got g of f. So that means f's inside g. So therefore, when I work this out, that 3 for g of x, that stays in the front there. Then I replace the x with my f of x. That becomes x minus 3 all squared plus 5. Now if I wanted to, I could then expand out my brackets. I would have 3x squared minus 6x plus 9 plus 5, which would give me 3x squared minus 18x plus 27 plus 5 gives me 32. Okay, and that would be my g of f of x function. Alright, I'm then going to look at the second one, which is f of g of x. And I like putting it in brackets like that. I don't really like writing just right next to each other. So in this case, what we're doing is we're putting g of x into f of x. So again, everything stays the same. I'm going to have that bracket out the front again. Now I'm just going to put in 3x minus 5, plus 5 minus 3 all squared. So I've put in my 3x plus 5 where my x was before. Now here I'm going to end up with 3x plus 2 all squared. And again, I could expand that out if I wanted to, and that would give me 9x squared. 3 times 2 is 6, times 2 again is 12, so plus 12x plus 4 on the end. That would be my expanded form. Alright, last one, f of x. So now I'm doing like putting f into f twice, and as it says there, it can also be called f squared of x. Okay, so I've got c f of x. Okay, so again, I'm going to keep everything kind of the same at the start. I've got my bracket there. Now where I've got x, I'm going to re-put in f of x again. So I'm going to have x minus 3 all squared. And then I've got minus 3 again, because again I'm keeping that original f of x the same. And then square that. Now if I wanted to expand this one out, and for time saving I might not do the entire thing. So that's my inside f of x expanded. So that would give me x squared minus 6x plus 6 all squared. And then I could expand that again if I wanted to. But I'm not going to, just to save you guys the time. But if you would like to, feel free. Alright, second example. So we've got f of x equals cos x, g of x equals 1 over x. So again, first one working out is g of f of x. So I'm going to work out g of f of x first, and then I'm going to sub in the pi on 3. So g of f of x, again I'm putting f into g. So that becomes 1 over cos x. Now g of f of pi on 3 is 1 over cos of pi on 3. Okay, now I'm just going to use my calculator here. So I've put this into radian mode. I don't think you guys have actually done radians yet, but when you do, anything that's got pi on it, that's what we call a radian measure. So if you haven't done that, then that's a shame. But to change your calculator, you go into setup, so shift menu setup, change your angle unit, and you want it in radians. Okay, it should have that R at the top there. Okay, so now when we're doing here, we're going to have 1 over cos of pi on 3. Okay, I can evaluate that and I get 2 as my answer. So equals to 2. Okay, so that's A. B, f of g of pi on 3. Okay, so again, I'm going to put, in this case, I'm putting g of x into f of x. Okay, so I've got cos of 1 over x. So f of g of pi on 3 is cos of 1 over pi on 3, which is the same, dividing fractions, we just flip that second one, so that becomes cos of 3 on pi. Okay, so I can chuck that one in here, so cos of 3 on pi. Okay, gives me 0.577. Okay. Okay. G of f of pi on 2. Now, it says here, explain why this is not possible. And I'm going to talk you through that a little bit, but not too much, because again, you go into this in more detail after the first kind of 4 chapters at Pure. So for this next bit, we have g of f of x. Now, we already worked out g of f of x was 1 over cos x. Okay, now I'm going to put in g of f of pi on 2. Now, if I work out what cos of pi on 2 is, okay, you can see that gives you 0. Okay, so cos of pi on 2 gives you 0. So g of f of pi on 2 would be 1 over 0. Okay, and you cannot divide by 0. Okay, so that means it's undefined. Alright. Lovely. Alright, last one. So we've got f of x is the absolute value of 2x minus 8. Now, that notation there, that means the same as f of x. Okay, and g of x is equal to x over 1 on 2. First one, I'm going to find f of g of 3. So again, we're putting g into f. So f of g, again, I'm going to work out x first. F of g of x, I've got the absolute value of 2 lots of x plus 1 on 2 minus 8. I'm going to simplify this a bit because I've got a divide by 2 and a times by 2 here, so I can cancel these out. And I'm left with the absolute value of x. Now, plus 1 minus 8 is negative 7. So f of g of 3 is the absolute value of 3 minus 7, okay, which is negative 4. And because we're taking the absolute value of that, that's then positive 4. Solve for f of g of x equals to x. Okay, so we've already solved what f of g of x is. That's x minus 7. Okay, so I want to solve for where that's equal to x. So again, when we're solving for absolute values, we split, and now we look at our positive case and our negative case. So we've got x minus 7 is equal to x. That's our positive case. Or we've got negative x minus 7 is equal to x. Okay, so in this case, x minus 7 is equal to x. If we subtract the x from that side, we end up with 0 is equal to negative 7, which cannot be true. Okay, so that means there's no solution there. X minus 7, negative x minus 7 is equal to x, so that's negative x plus 7 is equal to x. Okay, so then we're going to add the x on that side, and we end up with 2x is equal to 7, or x is equal to 7 over 2. Okay, so that's our solution there. Alright. Alright, so next thing is inverse function. So inverse functions perform an opposite operation to original function. We're familiar with that from, say, like squaring, square rooting, multiplying, dividing. They're all inverses. So inverse function, same thing as any of those kind of like operational inverses. It just undoes or does the opposite to what the original thing does. Okay, we write the inverse as f to the power of negative 1 of x. Just be careful, it's not actually a power though. If you do the power, that means it's a reciprocal. Inverse, it's just a notation thing, that negative 1. Okay, the domain of the inverse of x is the range of f of x. The graph of f of x and the inverse of x are reflections across that diagonal y equals f of x line. And if f of x is equal to the inverse of f of x, that's what we call a self-inverse. Okay, so there's just a picture of an inverse and a function. That would be an exponential and a logarithmic function, and you can see that they are symmetrical, through that line, and that the domain and the range would be opposite. Okay, inverses only exist for one-to-one functions. So for example, sine of x doesn't have one because it's a many-to-one function. Same with a quadratic, also a many to one, so it doesn't have an inverse either. We have to restrict the domain in order to have an inverse. So first example, we want to find the inverse function for f of x equals 3 over x minus 1. So finding the inverse is really easy. We just switch f and y. So inverse, I'm going to write let y equal x and x equal y. So we let, for that f of x, we're going to call that x, and then we're going to write that as 3 over y minus 1. Now I just solve for and rearrange it, so I have this function in terms of y. So I'm going to write that as x bracket y minus 1. So I've multiplied by y minus 1 equals to 3. Okay, I'm then going to divide through by x. So that gives me 3 over x, and then I'm going to add 1. So 3 over x plus 1. That's my inverse. Okay, second one. Function f of x equals root x minus 2, where x is greater than or equal to 2. So again, we specified that domain, state the range of f of x. So my range of f of x would be, okay, so if I sub in my smallest value, which is 2, I get 0. So my range is that y is greater than or equal to 0. Okay, B, we're going to find the function, the inverse function. So again, I'm going to swap my x and my y values around. So I end up with x equals root y minus 2. I'm going to square this side, cancel that square root, so that ends up with y minus 2 equals x squared, and then y equals x squared plus 2. Alrighty. My domain in this case, the domain is equal to the range of what the original was, so that's the x is greater than or equal to 0, and range is the same as the domain, so that y is greater than or equal to 2. We can see that would be true because if we subbed in 0 into this, we would have 2, so we're looking at all values of 2 and bigger. The next one, the sketching, I'm not actually going to sketch it just because I really want to finish this in the next 3 minutes, but I'll send you a picture of what those sketch graphs would look like. I've changed my mind. I've put it in here. So there's my line y equals x. Okay, there's my original function f of x, and there's my inverse function there. Okay, and you can see you've got the x-intercepts and then how it would kind of work from there. Alrighty, next example. Alright, so last one, we're looking at f of x equals x squared minus 3, where x is greater than or equal to 0. So find f of negative 1, so again we're going to switch x and y. Okay, so we end up with y squared equals x plus 3. Okay, now I take the square root, and I'm looking at the square root of x plus 3. Now you only need to consider the positive square root and not the negative square root, because we're looking at kind of the positive version of this function, and that'll make more sense when we're sketching f of the inverse of f of x. So I'm just going to quickly sketch it and come back to it, and just give me a second. Alright, so I've just drawn in my original f of x, which is x squared minus 3. So I can see I've got a y-intercept at negative 3 there, and it keeps going up. Now, when I'm drawing my inverse function, instead of having a y-intercept at negative 3, I now have an x-intercept at negative 3. And that should make sense as well, because you've got that horizontal translation of plus 3, which would move that 3 units towards the left. Okay. In this case, I'd also, at this point here, I would have an x-intercept for this function, our original, at root 3, which means that I'm going to have a y-intercept at root 3 on my inverse function. So that's going to come up and across, and then kind of look a little bit like that. Now, again, what I was talking about before, we have this, we could have kind of considered, if we wanted to, the positive and negative condition of this function. So we could have looked at the negative case of that square root, which would kind of continue this on looking like this. So it actually looks like a quadratic just flipped on its side. But we don't consider this negative case. And that's because that's not a reflection of our original function. Okay, so there we go. All right, now we want to look at what's the domain of our inverse. Well, our domain, let's go back to green again. My domain is that x is greater than or equal to negative 3. Okay, there's my domain, and then the last thing is we're going to solve the equation f of x equals to f to the inverse of f of x. So f of x equals to x squared minus 3. The inverse, here I'm just going to pause this and show you the answer because I'm running out of time. Okay, so they're equal at that y equals x line, so I can let f of x equal to x, go through quadratic formula, solve that. I only consider the positive case, and that's at -1 plus root